Hi there. The question of the day is, what is the rational root theorem? Okay. Remember, we're trying to find zeros of polynomial functions. Zeros, roots, x-intercepts. These all mean the same thing. Where does a line cross the x-intercept? What is the solution of p of x equals 0? And so the rational root theorem simply says that P over Q is a root of P of X if P is a factor of the constant term and Q is a factor of the lead coefficient. Okay, what does that mean? Well, let's make it simple here by finding an example. You've got P of X equals 10x to the third plus 9x squared minus 19x plus 6. Okay? So what we're going to look at is we're going to find, remember, P has to be a factor of the constant term. So this is your constant term. So what are the factors of 6? Okay? We got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. In other words, 1 times 6 would be 6, 2 times 3 will be 6, and so those are the factors of 6. Okay, and then Q has to be a factor of the lead coefficient. That's a lead coefficient. So what are the factors of 10? Plus or minus 1, plus or minus 10, plus or minus 2, plus or minus 5. Okay, so those are the factors of 10. So what we're going to do is we're going to create a list, and I'm going to go to plus or minus here because all of these things are plus or minus, but I'm going to create a list. I'm going to start with this one as a numerator and then make all these denominators. So let me show you what I mean. 1 over 1, 1 over 2, okay, 1 over 5, 1 over 10. See what I did? I took this 1. Remember, the P is on the top, and that's a factor of the constant term. Okay, so I just made factors of the constant term on top, one of the factors, and all these 4 factors. In other words, I'm creating all possible combinations with one of these factors on top and one of these factors on the bottom. Okay, so the next one is 2. 2 over 1, 2 over 2, 2 over 5, 2 over 10. Then there's 3. 3 over 1, 3 over 2, 3 over 5, 3 over 10. And then finally there's 6. 6 over 1, 6 over 2, 6 over 5, 6 over 10. I hope you understand what I did here. I just picked one of these each time on the top, and 1, 2, 3, 4 of these on the bottom. So it's just, now you're going to see some combinations like 3 over 1 or some duplications. 3 over 1 is the same as 6 over 2. Okay? 3 over 5 is the same as 6 over 10. What we have here is we have a list of possible roots of P of X. So the next step is to go to a graph, and we're going to take a look at this graph, and I think I've already put this in here. Let's see, go down here, and you see the top one here, 10x to the third plus 9x squared minus 19x plus 6. So I'm going to graph that, only I've already figured out my window for this. I want a window of -5 to 5 and -10 to 30. Okay, in the scale of 5. And I'll show you why. It just saves some time here. That gives me the best looking graph. Okay, so if I look at this graph, it looks like it passes through the x-axis at x equals -2, doesn't that? Now, rather than use the calc function on the calculator, I'm just going to use synthetic division, and I'll see if this -2 is indeed a solution. So -2. By the way, -2 appears right here. Remember, each one of these is plus or minus. It appears right here. Okay. So it's one of my lists, or one of the numbers on this list. Okay. So -2. And I've got the coefficients here, 10, 9, -19, and 6. Okay, so 10 comes straight down. -2 times 10 is -20. 9 plus a -20 is a -11. -2 times -11 is positive 22. -19 and positive 22 make positive 3. -2 times positive 3 is -6, and as you can see now we have a 0 remainder, and so that means that -2 is confirmed. Okay, that is one of the solutions. So now we can go from here. We can take a look at the graph again. We can see, well, maybe we can find another solution here. Well, here is one of those cases where you see where it looks like we're not quite sure what happens here. Okay, now there are a couple different possibilities. We might have, when you have something like this, okay, you might have, if you zoom in, you might have this. You might have two distinct possibilities. You might have this, where you have one solution there with a multiplicity of 2. Or you might have this, where you have, it doesn't cross the x-axis, in which case you have two non-real solutions. So let's just see what we have here by using these things here and zooming in on the graph. Okay, and using this list here again, when I zoom in, I can kind of tell whether this is going to work or not, or whether one of these is it. So let's do zoom box, and want to get just as close as I can here. Enter, and then I go to the right and then down and make a little box and then enter, and it's still kind of hard to see, isn't it? But it does look like, and so let me trace this thing and see what I can find here. Now that looks like it might be somewhere around 0.5, do you think? So let's try 0.5, okay, or 1/2. Now 1/2 is certainly one of my solutions, one of my possible solutions here, isn't it? So let me see if that's true. It's a possible, by the way, these are all possible solutions. These are not, these aren't all solutions. These are all possible solutions. So let's try 1/2. And again, we have 10, 9, -19, and 6. Now, after you do this synthetic division for a while, it becomes pretty automatic. So 10, half of 10 is 5. 9 plus 5 is 14. Half of 14 is 7. Gives you -12. Half of -12 is -6. And sure enough, we have another one, which is 1/2. And then, looking at the graph again, move the cursor over to the right a little bit. See if we can find that other intersection. It's pretty close there, isn't it? And it looks like 0.6. So let's see if and 0.6 is 3/5. So let's see if 3/5 is a solution. Again, we use synthetic division. 3/5, 10, 10, okay, 10, 9, -19, 6, okay, and erase my little point there I didn't need. 3/5 of 10 is 6, okay, And 9 plus 6 is 15. 3/5 of 15 is 9. Okay? And if I'm going too fast for you, just stop and do a little bit of multiplication in your head, but this is correct. Negative 19 plus 9 is negative 10, and 3/5 of negative 10 is negative 6. And so 6 and negative 6 make 0. And so here we have, now this is a third degree equation. You notice this right here? So that means if I've got 3 solutions, I really don't need to look any further. So 3/5, negative 2, 1/2, and 3/5. Those are my 3 solutions. Okay? That's how that works. And another way to use the to find a solutions is using the quadratic formula. Now, let's say I have q of x equals x to the third minus 2x squared minus 2x plus 1. Once again, I graph this thing, and I did graph it already, and I'm going to enter and enter. I've got x to the third minus 2x squared minus 2x plus 1. And my viewing window, I'm just going to go with negative 5 and 5, and then negative 10 and 10. Now, get in the habit when you're creating these graphs, get in the habit either going to zoom standard or else choosing a viewing window, because you remember we had to zoom in on a small tiny little area. We don't want to graph that in that area, so we want to graph a basic viewing window. So here once again we see it's a nice clean looking graph. I've got a solution here at negative 1, it looks like. So I'm going to use negative 1 with synthetic division. I got negative 1, and I got 1, negative 2, and 1. So bring the 1 down. Negative 1 times 1 is negative 1, negative 3. So that's a positive 3, which gives me 1, and negative 1, and 0. So negative 1 is a solution, which means x plus 1 is a factor. The other factor I've got right here, okay? X squared minus 3x plus 1. So that equals 0. And so that means that I can use the quadratic formula on this. I've got a equals 1, b equals negative 3, c equals 1. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a equals negative b is a positive 3 because b is negative 3 plus or minus the square root of 9 minus a and c are both 1, so it's 9 minus 4 all over 2 times 1, which is 2. Simplified, we have 3 plus or minus the square root of 5 all over 2. This is an exact answer. And so here I have my 3 solutions. X equals negative 1 and x equals both of these. Now if you look at the graph here, okay, that probably wouldn't have been easy to find those. You can get them in the nearest hundredth, but if the question asks you for an exact answer, you probably wouldn't be able to find this from the graph. Okay? And so that's enough for today. Thank you very much.